Okay, good evening, everybody. I don't know, man. I'm tired, but let's do this anyway. We'll see if I can get through it. Let's go. I realized, first of all, A is in the right place. I meant for A to be f of x plus g of x. Then I didn't mean to go down like this. I meant for it to go from adding to then subtracting to then multiplying. Multiplying must be back here. Multiplying is E. These things are all jumbled. I meant for it to make more sense, but I blew it, and that's fine. We'll just kind of go in whatever order it is. But we're kind of working down columns on your sheets. For me, that means I turn the page. I can continue down this column. Then I'm going to go back a page, back up to D, E, F. Okay? Whatever it is, you'll follow along with me, I think. It's laid out a little different from your sheet, but you guys are smart kids, so you'll be fine. So anyway, for this first pairing of functions, we got a quadratic and another quadratic, so this should actually be pretty simple, especially for the sum function, because you should notice the negative x squared and the positive x squared, they're going to cancel out right away. So our sum function is just going to be a linear function, but if I was taking this slow, I'd write the whole thing out. F of x is going to be this first quadratic. We can write all three terms out, you know. So it's negative x squared plus x plus 6. Then we're going to add to that the other function, which is the other quadratic, x squared minus 9. It's a dark blue. And like I said, I'll lock that down. The 2x squareds are going to cancel. That's selecting everything. Alright, forget it. Unlock. No unlock. Okay. So what are we going to get? We're going to go ahead and let them cancel. Those cancel. So we get x minus 3. That's it. Now looking at this function, because it's linear, you should say that its domain is real numbers, and that's fine. But we said that with functions defined as the sum of two other functions, we got to make sure we consider the original function's domains. So you know, what's the domain of function f? Well, it's quadratic, so it's real numbers. What's the domain of g? Well, it's quadratic, so it's real numbers. So this is not a terribly interesting question. If our two domains are real numbers, then the intersection there is also real numbers. So this function's domain is real numbers, like we expected it would be. That does happen more often than not, honestly, is that you get your resultant function, you think about what its domain would be, and then you're right. There aren't extra restrictions, but sometimes there are those sneaky ones that we've seen before. Anyway, after the sum function, we should probably do the difference function. So we could jump to C, part C, I guess, and then backtrack, but I don't want to get too confusing, but doing C. So for this, f of x is coming first, so it's negative x squared plus x plus 6, then minus the x squared minus 9. So again, the big thing to remember is this negative affects both of these terms. So when we go to solve, we're going to have negative x squared minus x squared for minus 2x squared. Then we're going to have an x, and there's no x terms in here, so that's just going to stay a plus x. Then we've got a positive 6 minus a negative 9, so plus 9. So 6 plus 9 is 15. And that's it. That would be our rule. So this thing factorable? There's a chance it's factorable. Alright, let's factor it. I would want your final answer factored, so let me not be lazy. We do have to check and see. First thing I would do is factor out the negative sign, because negative leading coefficients, in my opinion, make factoring much harder. So we'll go 2x squared plus x. Oopsies, we're changing all the signs as we factor out a negative. So minus x minus 15. Then now that we've got a leading coefficient of 2, you know you got to multiply. So 2 times negative 15 is negative 30. And we're looking for factors that add up to negative 1. And that's 5 and 6, so we are factorable. So we're going to go with a positive 5 and a negative 6. Again, you guys have seen me factor like this before. We'll do it again. We've got our leading negative. We know that to get a 2x squared, we need a 2x and an x. We know that to get a factor of 6, we're going to multiply by 2. So I'd put a factor of negative 3 right here. Then when I do my outer products, that's going to generate that negative 6. You want a factor of 5, you just put a plus 5 here, because that's going to get multiplied when we do the inner products. That gives us a 5x. We can double check this, but I'm sure I'm good. 2x and x is 2x squared. The outers give me negative 6x. The inners give me plus 5x. The sum there is minus x. And 5 times negative 3 is negative 15. So we're definitely factored correctly. And that is what you ought to give me, is your answer in factored form. But again, whatever. I'm more concerned with the domain. And you should be imagining that the domain of a quadratic is all reals. And in fact, we know it definitely is, because the two original functions both had domains of all reals. And so the intersection of all reals with all reals is all reals. Where do we go from here? Probably the product function. That's what I meant, at least. We'll do E. So for the product function, this might be tricky for some of y'all. I'm not sure if all of y'all remember this, but order doesn't matter. F of x times g of x is the same as g of x times f of x. It's just like multiplying numbers. So I would put the two terms first, just because it's what I'm accustomed to. But if I do x squared minus 9 times negative x squared plus x plus 6, then to multiply here, you're not foiling. A better way to think of this is you're taking the first term and distributing it in onto all three terms. Then you take the second term and you distribute that in into all three terms. When you're done with that, you should have 6 terms, and you can combine all the like terms. So distributing in x squared gives me negative x to the 4th, and then plus x cubed, and then plus 6x squared. Then I distribute the next term, and I like to keep everything lined up. So if I get a positive 9x squared, I'm going to list that under the other x squared terms. And then as the 9 distributes through, it's going to give me more terms out here. So I'll get a negative 9x. That starts its own new column of x terms. And then I get negative 54. And that's its own column of whole numbers. But now that I've done all that, I see that my final answer is going to be the 4th power function, or a quartic function, negative x to the 4th. I hate that my little tablet does that. Ay, ay, ay. I kind of hate this tablet. Okay, draw. That's a good 4. Plus x cubed plus 15x squared minus 9x minus 54. There you go. Now I know what you're thinking. You're thinking, hey, Mr. F, a second ago, you said you wanted your answer factored. And you very decidedly just took this problem and expanded it out. And that's true. You got me. You got me. You win. Maybe this isn't really what I wanted. But the alternative would have been listing this product as what? We would factor this. It's a difference of squares. So it would be x plus 3, x minus 3. This guy's factorable. I think so. Again, we'd factor out the negative sign. So go negative x squared minus x minus 6. That factors down to x minus 3, x plus 2. Yeah, that's right. So we end up with a leading negative, an x minus 3, and an x plus 2. So yeah, you know what? That answer is better. But you know what answer is best? Making sure that you express these two with a power of 2. So it would be the opposite of x plus 3 multiplied by x minus 3 squared plus x, or times x plus 2. So probably this blue answer is the answer I really wanted. So if you're wondering why I spent all that time taking this thing and expanding it, well, you know it's because being able to expand your answer is important too. So here's your answer as a standard form polynomial. And down here in the blue box, this is your answer in factored form as the product of these 1, 2, 3, 4 linear factors. Which makes sense. There's 4 x's here. You would end up, when you expanded it, with a quartic function. Hopefully you guys are absorbing all the words I'm saying right there. That's vocabulary that, yes, you are supposed to know. So anyway, that's another one put down. Well, no, it's not put down yet. We're supposed to give the domain, but you guys know by now that the domain is all reals, because the domain is based on the domains of the original functions, which are still both all reals. So nothing very interesting in the domain department. But at least now we can slip back and do part B, which is a quotient function. Part B has the simpler quadratic in the numerator and the more complicated one in the denominator. All right, there's your quotient function. I kind of already told you a second ago that we want this factored. So we should be looking at a rational function whose numerator is x plus 3, x minus 3. And whose denominator is negative x minus 3? No, plus. No, minus, because I factored out the negative. If I'm losing anybody, you'd want to factor out the negative first. And then you've got the x squared minus x minus 6, which is why I want an x minus 3 and an x plus 2. That would be the correct factorization. Okay, well now we see we've got the x minus 3 and the x minus 3 as a shared factor of the top and bottom, so we can cancel that out. But we saw a problem like this before too, and I mentioned that we're going to go x plus 3 in the numerator, x plus 2 in the denominator. But because we've canceled out the x minus 3, we've kind of lost some information about the fact that 3 should not be in our domain. So we express that. We say, hey, don't let x be 3, because that's supposed to cause a discontinuity. So you have to physically write it in there. But that'll do it. Now you're also being asked to write the domain. And the way I see it, x sure as heck can't be negative 2, because that would cause division by 0. It also can't be 3, because that would cause division by 0. And typically that's it. So what is it? Yeah, that's it. We definitely want to make sure the denominator function never equals 0. And by factoring it, we've made it very easy to see that the zeros are positive 3 and negative 2. So you just list those. Our domain would be all reals, except for the small little set that contains negative 2 and 3. So that's it for B, so we can go back and do D, which just switches the order. So now the complicated function's in the numerator, which I'm going to go ahead and just factor immediately. It's negative x minus 3, x plus 2. The denominator is the difference of squares, which still factors as x minus 3, x plus 2. Wait a minute, x plus 3. Okay, cancel those, womp womp. And then you've got your final answer for the algebraic rule for this function. It would be the opposite of x plus 2 over x plus 3. Here we again lost the fact that x can't be 3, so we would indicate that. So we'd say x cannot equal 3. You don't have to indicate that negative 3 is not in the domain, because that factor is still there. Your audience, so to speak, can see that x is not going to be allowed to equal negative 3. The reason we list it over here as a restriction is because our audience has lost the fact that these factors used to be there and we canceled them. If this is all we showed in the end, you'd have no reason to know that x can't equal 3. That's why you have to write it out yourself. Anyway, our domain is going to be roughly the same. It's g of x, who's in the denominator now, generating two zeros, one of them at -3, the other one at +3. So our domain is RILs except for -3 and also +3. Okay, so that's that. E is done. Is F done? The compositions. Okay, forgot about them. All right, let's get them done. In red, orange. All right, this time G is the function that we're substituting in. So I guess we're looking at the opposite of x squared minus 9 all squared plus x squared minus 9 plus 6. All right, this is a little bit gross, not exactly what I intended, but x squared minus 9 squared is an x squared minus 9 times an x squared minus 9. So you'd FOIL that. Just go first order and or last on it. Bring your negative sign down with you though so you don't lose it. But this would be x to the 4th. And then -9 x squared and negative more 9x squared, so you'd get -18 x squared. And finally you get plus 81. And then the rest is, well, we can go ahead and simplify a little. The 9 and the 6 at least. So this would be adding on an extra x squared and taking away 3. Alright, so the only thing left now is this leading negative I distributed in so that I can simplify. You get -x to the 4th plus 18x squared. Sure, minus 81. And then plus x squared and minus 3. Which means your final answer, you just combine like terms. You've got 18x squareds and one more, so that'll be 19. So it'll be -x to the 4th plus 19x squared. And then minus 84. And I don't even want to know if that's factorable. Is it factorable? Are there factors of 84 that will give us 19? I don't tend to care. But maybe we'll check. We can check. Go to the thing. We're going to factor whatever we just had, x to the 4th. Plus 19x squared minus 84. Go. It is factorable. Not for crying out loud. Alright, then fine. You gotta factor it. I should have just checked. I mean, the only factors of 84 are 7 and 12. I guess I should have just checked, but I was being lazy. I guess then I wanted to let you guys know as well that if you're using something like this, if you're using a photo math or an online algebra, what do we call it? Computer algebra system, CAS. If you're using a computer algebra system, I don't mind if you're doing it in your homework just to eliminate some of the grunt work, especially if you know how to do the thing and you're just trying to save time. Like, that's not a big deal. So let's bring that back. I still would recommend you factor the negative out because I don't like it. Get it out of your way. Then you've got x to the 4th minus 19x squared and plus 84. And yeah, we saw that that is factorable because we factor out the leading negative, so we get an x squared times an x squared. And really the only factors that make sense are the ones that work. To get an 84, it's 7 and 12, we said. Right, because it's a multiple of 12. And those do give 19. It's got to be minus for both, so it's minus 7 minus 12. But there's your final factored form. We can't factor either any further. So it's cool to stop there. What's our domain? The domain stuff is super boring because, again, we're working with two functions whose domains are both RL numbers. So this thing here, this result, is a quartic polynomial. It has a domain of RLs. Then if we consider the domain of the inner function g of x, its domain was RLs. So we don't need any restrictions on our domain. Our domain is going to be RLs. So there's that. Let's do the other one. This could be different because typically when you reverse the order of a composition, you get something completely different. And we definitely will. We're going to take the big three-termed quadratic, plug it in for x squared here. So that means we're going to get negative x squared plus x plus 6. And that whole thing's going to be squared. And then we'll take 9 away from that result. So expanding this will be kind of a pain in the butt. We'll have 3 terms times 3 terms, but it's doable if you take it slow. X squared plus x plus 6 is getting multiplied by an x negative x squared plus x plus 6. And don't forget there's a minus 9 on the end. So now, like I said, you're going to take this first term, distribute it through. Then you're going to take this second term and distribute it through. Then you're going to take this third term and distribute it through. We're going to end up with 9 terms by the time we're done. But no big deal. We can do it. So we're going to get positive x to the 4th. And then minus x cubed. And minus 6x squared. Then we'll distribute this x and we'll get negative x cubed, which I'll align with the other x cubed. Then we'll get just a plus x squared, which I'll align with the other x squareds. And x times 6 will give me a 6x, which gets its own new column, so that's a linear term. Now we're distributing 6, so you'll get negative 6x squared, will go in this column, and a plus 6x, and a plus 36. So now I can add all this. And we're literally just adding things that are in the same column. So this x to the 4th is like a unique term. We've got these 2 x cubes. We've got 3 x squareds, 2 x's, and then another unique term, the constant at 36. So putting all that together, I guess we are getting x to the 4th minus 2x cubed. What? Minus 12 plus 1, so minus 11. Plus 12x plus 36. So, can that be factored? Maybe. Do I wanna? No. Should we anyway? Maybe. Go back to your computer algebra system. See what I care. X to the 4th minus 2x cubed. No leading negative this time, right? Right. Minus 2x cubed, x squared, oops, squared, need another x. What else is there? So it's minus 11x squared plus 12x. Plus 36? Plus 36. Okay, factor that. It can be factored. Interesting. Yeah. Are we going to get into this mess using the rational root theorem to break things down, break them down, break them down? Yeah, someday we'll probably get into it. Not today, though. So x plus 2x minus 3, both squared. Fine. Again, I wouldn't expect you to be factoring quartic functions at this point, but it's nice to know that the answer could be expressed as x plus 2x minus 3. Notice this is squared. The other one is x minus 3 squared. So that is giving us our grand total of 4 x's. We get 2 here, 2 here. So we are getting x to the 4th. All right, and then, you know, super anticlimactically, what's our domain? It is just RL numbers. There's no restrictions that we need to care about. So this problem, for sure, was largely about reviewing the algebra, making sure that you could, you know, do these operations. That took a while. We're 25 minutes deep into this. All right, cool. I don't know. I'm stopping the video, I think. I may just split this into 4 videos, one for each problem, because I don't super feel like moving on right now. I'm pretty tired. But anyway, hopefully this helps. I'm sure it helps. See ya.